Real men of genius.
Real men of genius.
This video is over the history of the atomic theory. It's going to walk you through their thought process before they came across the actual true model of the atom. You're going to be required to know who proposed what, if it was true, and if it was not true, why it was not true. So first off, what is an atom? It's the smallest particle of matter which will exhibit the properties of that element. And we'll go through in a different video about what actually makes up an atom. So the first guy we need to talk about is John Dalton. He proposed that all elements are composed of very small particles called atoms, which are indivisible. You can think to yourself, by what you know at this point, is that true or not? It is not. Atoms are not indivisible except by a nuclear reaction. But when we're going through this, we're talking about chemical reactions, not nuclear reactions. So don't think of any exceptions as you're going through here. The next thing he proposed is all atoms of the same element are identical. That's not true. All atoms of the same elements are not identical. You have what's something called isotopes. I'll go ahead and put that word right up here. What really happens is atoms have protons and neutrons, and you have different atoms of the same elements that have the same amount of protons, so it's still the same element, but they can have different number of neutrons. They also propose atoms of different elements are, in fact, different. That sounds so simple, it has to be true, because it is. They propose atoms of different elements can combine with each other only in simple whole number ratios to form compounds. It sounds true because it is. Those big, long, complex definitions, they always turn out to be true. And then he proposed that chemical reactions occur when atoms are separated, joined, arranged. That one was also true as well. Remember, they can only be separated or changed by nuclear reactions, but we're talking about chemical reactions when we're going through atomic theory. J.J. Thompson, what did he discover? He discovered that electrons are negatively charged. And you can see this little funky little thing flicking over here on the right. That's the cathode ray over here. And that's what he really worked with. And I'll go through and explain this. So he discovered that electrons are negative with the cathode ray experiment. So what was the proposition? Electrons are negatively charged particles. And we, of course, know by now that that is a true statement. How does this cathode ray experiment actually work? Well, what happened is he has this purple beam of electrons, and he's shooting this electron through, and it's hitting this thing over here at the end. Now, what's going to happen if we mix a positive charge with a negative charge is that the positive charge and negative charge are going to begin to attract each other. So once he turns on this little yellow thing, this is a magnetic field that has a positive end up here and a negative end down here. So before he turns the magnetic field on, it's hitting right here on the cathode array. Once he turns it on, he starts to see that the electrons are now hitting way up here. And that's because the positive end of the electric field and the negatively charged electrons are attracting each other, causing them to hit in different locations. That's how that cathode ray experiment actually worked. So his second proposition is the plum pudding model. He thought that protons, the positively charged protons and negatively charged electrons were mixed together. The large pieces were swimming together. It just doesn't look right, and it shouldn't look right. And he's also got his negative charges bigger than the positive charges. We know, based on what you've seen just in pictures, that you have your positive charges in one centralized nucleus, your negative charges are kind of floating around in orbitals. So that's why it was not true. Okay, Ernest Rutherford. What was his proposition? He's going to take that plum pudding model, and he's going to say that's not right. He's going to say the atom is mostly space, and the positive charge is located in a very small central nucleus. Of course it's true. We just talked about why the plum pudding model was wrong. Ernest Rutherford proved that it was wrong and that his was right. How did he come about knowing that his idea of the atom was actually true? He did the gold foil experiment, and you can see the little definition right there. But you can see the gold foil right here, that gold piece. Now he's going to shoot alpha particles at this gold foil. So the alpha particles are coming right here. Now on the outside, he's got some type of material that's detecting alpha particles hitting it. And they tend to glow. That's what these little yellow things are down here. They're glowing when the alpha particles hit it. You can see that some come straight through. Some get deflected way over here, some get deflected over here, some get deflected here, and some came straight back. So what's deflecting these particles? And he came to the conclusion, because they're hitting a small positive charged, dense nucleus, the alpha particles are going to get deflected in different directions. If it gets hit square on, it's going to be reflected right back towards that light block that's shooting alpha particles. If it hits just a part of it, it's going to be deflected to the side. And if it doesn't hit the nucleus, it's going to travel right through. So that's how we knew the plum pudding model was incorrect. and that the negative electrons are actually outside the nucleus, and the nucleus contain the positive charges. Our next guy, Niels Bohr. What did he propose? Electrons are in energy levels. So the farther an electron is from the nucleus, the higher its energy, which means the more likely it is to react. And we know that that is true. And we'll talk more about energy levels in another video. He also proposed a planetary model in which electrons orbit the nucleus just like the planets orbit the sun. That's not true. They actually have different kind of sub-levels and suborbitals that they travel in, and we'll talk about that in another video as well. But you still need to know what he proposed, and that electrons are in energy levels, but they do not circle like the sun. They circle in orbitals.
Just stay out of my way, or you'll pay. Listen to what I say.
How about I just go eat some hay? I can make things out of clay and lay by the bay. I just may. What do you say?